And I've got question 1 up. So piecewise functions, you have seen this before. There's nothing new here about this, but yeah, being in the college class, I would argue they're, they do a little bit more rigorous job putting together questions. So
Mhm.
when you see a problem like this one, this is kind of the expected type of problem you'll be asked to do on a test. So it says a charity organization orders shirts from a shirt design company to create custom shirts for charity events. The price for creating and printing the shirts is as follows. Design and setup fee is $50, and the first 90 shirts you get at $7.50 each. Then any more shirts after that price are $6.50 each. How much is the cost for the charity to order 150 shirts? All right, so the way to answer this is that there is the cost, if you want it in words, it's the setup plus the 90 shirts that are at $750 plus the 60 shirts that are at $650. So does that make sense? Because you have to pay the setup fee one time, then you have to
Mhm.
buy some amount of shirts. Well, first 90 you're getting at the higher price, and then the next 60 you're getting at the lower price. Does that look okay to you?
Yeah.
All right. So the setup here is 50 plus 90 times 750 plus 60 times 650, like that. Is that okay?
Yeah.
Clear. All right, so go ahead and grab your calculator and see what you come up with for that, and get that down here for your answer.
I got $1,115.
I agree, and that's what they're looking for here for part A. All right, so part B is a little bit more involved. The part B, this says find a formula for the function that represents the total cost of ordering N shirts. Make sure to define your variables and use mathematical notation. All right, so we know that N is the number of shirts, and I guess we'll use C of N to represent the total cost, like that.
Okay.
So now this is a piecewise function. So the piecewise function is organized this way. It's got a piece up here at the top and a piece up here at the bottom. It could have more than one piece, but for this one, it's got just two. So if you order 0 shirts all the way up to 90 shirts, the first formula is valid. Okay, so the reason is there's a break point. The break point is when you order more than 90 shirts. But since you can order as many shirts as you want, if you order any shirts over 90, this other formula applies, and we're gonna figure those out, but that is what it is. You have to you actually first set up the domain. You set up the the boundaries for each of these.
Okay.
So for the first one, there's that setup cost. That setup cost of $50 plus you pay 7.5 for every shirt. Is that clear?
Yeah.
Okay. Now, when you buy more than 90 shirts, here's the thing, you've already paid the setup cost and you've already paid for 90 shirts. So to figure this next part out, you have to basically evaluate this at 90. You have to figure out
Okay.
how much do the first 90 shirts cost. Let me know what you come up with for that.
Wait, I'm sorry. How do you figure that out?
You
Which
have to
part do you use?
you have to evaluate this top piece at the end point. You want to know how much it costs to make 90 shirts, because that leads into the next part.
Oh, okay.
So I'm asking you to put 90 in for N.
Okay. Is it 725?
Yes, so it's 725 plus. Now you might think it's 6.5 N, but the problem is you only get 6.5 for the shirt when you buy more than 90. So you have to subtract the first 90 from that. So imagine that it's 91. You want 91 shirts. Well, you're only getting that one shirt over 90 at $6.50.
Okay.
All right, so that is everything for part B. I guess we can move on to question 2. Now, when you're ready for us to do that.
I'm ready.
New question here. This is the kind of the normal consideration when you're working here. It says a chef earns $28.50 per hour for regular 40-hour work week. So what that means is you get $28.50 per hour for all the 40 hours that you work, but you can work overtime. And a lot of people like overtime because they get paid, in this case, double time. So sometimes the chef works over 40 hours in a week and earns double time. Double means, in this case, double, $57 per hour for the extra work. This means that the chef's hourly rate for the additional hours over 40 hours per week is double the normal rate. If the chef works 46 per hours in 1 week, how much would the chef earn? Make sure you include units. So out of that 46.5 hours, 40 are at the $28.50. But the 6.5 over it, they're at $57. And this, it depends on the industry you're in. This is true to some extent. I don't know if it's double time. I think you get time and a half and then double time, or they've got different. But you can make quite a bit of money if you enter into a scenario where you get this higher rate. So the chef's pay for the week is 40 times 28.5 plus 6.5 times 57.
Okay.
All right, so go ahead and calculate that for us and let me know what you come up with.
$1510.5.
So $1,510.50.
Yeah.
Right. Any questions on that before we move on to part B?
Um, so for like problems like this, I would say the hardest part for me is kind of like picking out the pieces to put them in the equation. Like I don't really understand like the order and where to put them, if that makes sense.
Yeah, I mean, in terms of what you would write, I mean, you could put all of this in the box here. Um, but it's hours times rate plus hours times rate. You were lifeguarding at some point, maybe?
Um, I
Oh,
was not.
you had a job though. You were doing something. Mom said a while back you had a job. You worked
Yeah.
some number of hours and you got some number of pay.
Hmm.
That's what you have to take away and remember.
Okay.
Hours times rate.
Okay.
Okay. Were you asking what to put in the box here, or were you just asking more, I guess, high level, like what we're doing in this problem?
I was just kind of asking like what to do in this problem to make the equation.
Okay, so part B is where we actually write the function. And that's, I mean, that's what we did here. And that's more involved. This is just asking, they're just picking a certain number of hours and they want you to piece together that part of it comes from the initial pay and part of it comes from the overtime. You know, think of this as regular and this is the double time pay.
Hmm.
Right. So let's move on to part B. Create a piecewise linear function to represent the amount the chef can earn in 1 week if the chef works X hours. All right. So X is the number of hours worked. And then we have to create a function. So I guess we'll go f of X is the total pay for the week. I'm just choosing f of X arbitrarily. You can use many other options.
Okay.
Okay. Now, again, this is defined in pieces. F of X is defined as a piecewise function. There's a piece for the first 40 hours that you work.
Okay.
And then there's a piece for after that, which we'll talk about in a moment. So the first one's pretty straightforward. If you work 1 hour, you get paid 28.50. If you work 2 hours, you get 2 times 28.50. 3 hours, 3 times 28.50. So
Hmm.
your total pay is 28.5 times X.
Okay.
All right. So the next part, and this we did this in the last room, is you always evaluate the initial one at the end point. You want to know how much you get for the first 40 hours. So could you
Okay.
calculate that for us, please?
Is it 1140?
Okay. Now you're adding to that the rate you get for the hours over 40. So it's not 57 times X. Okay.
Hmm.
It's the hours more than 40 that you work. So you always subtract out the offset on that.
Okay.
All right, so there's your function. Now we got to talk a little about the domain. I don't know if you know how many hours are in a week, but you can take 7 and multiply by 24 and get that number. And I guess in theory, someone could work that many hours in a week. And if you ever
Okay.
thought about it, I mean, if you could stay up 7 hours, I mean, even like the SEAL teams that train, they don't say stay up 7 days in a week. I mean, they might keep up 3 or 4 days, but there is a limit to how long you can stay awake. But
Yeah.
I guess in theory, you could be up 160, you could work 168 hours in a week.
Hmm.
So that is, and that leads into part C. But any questions on this?
Not so far.
Okay, now I'll just point this out on the second piece, you always are subtracting out that initial value there, just like we did in the previous one. You're always subtracting out that number from the breakpoint number.
Hmm.
All right, so part C is what is the appropriate domain for the function? So the domain is, well, 0 to we can, I mean, I guess you guys are, I guess it's 0 to 168.
Hmm.
But I mean, you might throw out a question like, well, is it even possible to work an entire week? I mean, people that work 60 hours or work, you consider that to be a lot. You got to sleep, but I guess you could work every hour of the day.
Hmm.
So how do you know? I guess you could say it's the number of hours in a week. Um, question. Oh, graph this function. Okay. All right. So just to kind of get going on question 3, I'm probably going to need the link there or the data, depending on what's in that window. But to graph this original one, we got to go. Well, we're going to go to Desmos and do that here. Have you talked any more about whether you're going to be able to use Desmos or not?
I don't think we're going to be able to use Desmos on the quiz.
Okay. Well, you probably won't get any questions like this, but let me go ahead and graph it here for you. Right, so let me 0 to, I don't know, 2000. 0 to, I don't know, 80. Right, so I've got a graph of this now created, and what your instructors want to see is they want to see the first graph connect to the other one,
Hmm.
because they do join together. They, like, where one ends, the other must begin. There's not like this jump in pay.
Okay.
So make sure you label here. This is the hours work. This is the pay, dollars, and yeah, I don't know how far to go. I mean, 60 hours seems like a lot of hours to work. As someone who's done that, I mean, I just Are you able to drop that link in the chat or give me
Oh, yes, I can.
or take a screenshot of it, whatever it is? I may have been able to type it in here. Here it says, not it. Says to use the information to create a piecewise defined function for one monthly bill total charge as a function of cubic feet used for up to 15 CC. I've used the monthly service charge tables. That's not the right one. That's the right one. Okay. They sure make this difficult. So it's a little further down on the page.
Okay.
Up to
I
50.
see it.
Okay, use the for 5/8 inch meter. Okay. And use the usage charges tables for a single family. Okay, I see. So we have to use this for a single family. All right, here we go. Not sure I totally understand this yet. I got to keep looking at the pictures. Use this information to create a piecewise defined function for one monthly bill's total charge as a function of the cubic feet used up to 15 cubic feet. Okay. Use the monthly service charge table. Okay, no, these charge. I got it. All right. So we have enough here to do this for 3.1a. So here's the information we need. They've maybe overcomplicated this. We need that. That's like the service charge. That's the standard one. And then we're going to use these two rates here. Everything else is not needed.
Okay.
Okay. And it says to not fit other units. All right, so let's get going on this. So the first variable X is the number of CCF used. So cubic feet of water, which is
Mhm.
748 gallons. I mean, that's like flushing your toilet 748 times. Probably a lot of other, I don't know. I don't even know how much water I use or anyone uses, but probably more than we think. So the function, so the C of X, the cost, it's the total cost to the customer, total cost per month. Okay. Now we can create our piecewise function here. So our piecewise function is first valid from 1 to 7 CCFs. So when X is between 1 and 7.
Okay.
The other one is good from 8 to 15. So no matter whether you use 1 PCF or 15 CCFs, you always have this service charge. There's always this 16.33 plus the amount you pay 2.07 times X.
Okay.
All right. Now, just like the others, you have to evaluate this first one at that endpoint. So could you do that for us, please?
Wait, sorry, which numbers am I using?
The endpoint. It's like in the previous one here. Brad, you put 40 in for X.
Oh, okay. Is it 30.82?
Fine. And then what you're adding to it is the new cost, $3.82. Now this one's a little bit different, like you get charged more the more water you use. But it's not times X because you're not getting charged for all of them. It's only the ones over 7 that you're using. So the second one always has an X minus that endpoint in it.
Okay.
Right. So that is that. Now, what I don't see, and I'm just looking at your image numbers here, feels like we're missing, maybe it is there. I don't see 3.1. There it is. Okay, graph the function. So we have to graph this just like previous ones. And you might ask your teacher if you're going to be expected to graph these without technology. Could be a little rough. It's impossible, but it's definitely more difficult. And then 30.82 plus. All right, now the oddity of this one is that there's this like gap between them. And I don't know what to suggest, but there is truly this sort of this gap here. Just make this a little, it's the reason is because these endpoints don't match. But when you looked in the table, they don't match either. It says 1 to 7, 8 to 15. You might ask your teacher about that. I don't know. But this is the CCFs that you're using. This is the amount that you're paying. You might want to label the endpoints. Let me see if I can make the graph a little better. This one looks really bad, actually. So let me snip in a better graph. That's CCFs, scholars. Okay, part C, whenever you're ready, let me know.
I'm ready.
So part C, we're actually going back to the piecewise stuff here. Reuse this. Oops, copy that. So we're asked to find the cost for 12 cubic feet. So what that means is you have to decide, well, which one am I using? Is 12 between 1 and 7, or is 12 between 8 and 15?
8 and 15.
Right, so you put 12 into the second function. The cost of 12 is 30.82 plus 3.82 times 12 minus 7. Do you have an answer for me on this one?
Is it 49.92?
That sounds good. That is in dollars. You might want to throw those units in. Let me know when you're ready to move on to question 4.
I'm ready.
These are they're really tough for students, these transformation problems, and do my best to make them more manageable for you. I think it's better to work the problem from a table. So I want
Mhm.
us to label these 4 points. We're going to need them for the transformation. So the first one there is -2, 0, 0, 2, 2, 0. I guess we could even do this one. We probably should do that one there. That's 4, 4, -2, and 6, 0, like that. Is that okay?
Okay.
All right, now
Yeah.
this is where it gets tough. It's because this was almost never covered well in high school. The transformation they want here. So to neatly graph the transformation, you have to know what these do. Now the -3, I think most students figure out pretty well. -3 means down 3.
Mhm.
So that means you're going to take your y values and subtract 3. That's no big deal. The 2, you typically think, well, it must be multiplication. But because it's inside the function, it's the reciprocal of what you think it should be, or the flip. So instead of multiplying 2, you're actually dividing by 2. You're going to multiply your x values by 1/2.
Mhm.
Okay, whenever it's inside, it's always reciprocal opposite of what you think it should be. So now what we have to do is take these 5 points and transform them. Okay. So we take the x value and multiply it by 1/2 in all of them. And I would do them all together. So like -1, 0, 1, 2, and 3, like that.
Mhm.
And then the y values, you're going to subtract 3 from each of them. -3, -1, -3, -5, -3. All right, so now what you can do is you can graph this new one. I'm gonna very carefully try to do that over here. I'll do that in blue. So -1, -3. And that corresponds to this original point here. Let's keep that in mind. The next one is 0, -1, 1, -3, 2, -5, which we can't really get, and then 3, -3 there. So if you kind of just trace it the way it looked there, you can see that that last part I didn't get real well. See that it kind of comes down and goes up. And then it shoots up like that. And that's what they're looking for.
Okay.
Does 4.2 only have, I'm sorry, does 4 only have the two parts, part A and part B?
Mm, oh, it has 4 parts.
Four parts. Must be in the other email then. There it is. Yeah. Okay. Wow. Lots to do. All right. So for the next part here, you have to determine the domain and range. So to do that, you really go back to the graph. The thing that maybe isn't quite clear is that this arrow goes up forever. It goes up forever and left forever. So this does as well. So in the domain, it's still it's unchanged. It is minus infinity 2, and you need the rightmost x value. So what is the rightmost x value that you see?
Um,
The blue.
660. Oh, in the blue.
That's yeah, in blue, the transformed one.
It's 3.
Yes. Okay. Now the range, and you can think of you can think of the domain as left to right. The range is bottom to top. Okay. So how
Okay.
far down does it go? What's the bottommost point? What's the lowest y value that you see in this list here?
-5.
-5. So it's bracket -5, comma, and then the question is, well, how far up does the graph go? How far up does the graph go?
Infinity.
Infinity. So there you go. So parts C and D probably will go a little faster. It's the same type of problem. We're going to basically do the exact same steps. We're going to take the points, we're going to transform them, and then we're going to graph them, and then we're going to state the domain and range. So let me know when we can do that. I hope that stuff's being covered in class. I hope you're seeing
Yeah.
this. All right, so let me go grab these points here. All right. Okay, so we have to know, like, what are these transformations? So this one I'm highlighting, this x plus 2, because it's inside the function. Instead of it being right, it's left 2. It's left 2. So you're gonna take all your x values and subtract 2.
Okay.
Is that okay?
hmm
Now this negative is a flip or reflection over the x-axis. It affects the y values. The y values are all negated. They're all negated.
Okay.
Okay. So I've got these 5 values here. So first thing we're going to do is we're going to move the x. We're going to subtract 2 from all the x's. So I'd like you to do that. Someone should subtract 2 from all the x's here and give those to me in this list.
I got -4, -2, 0, 2, and 4.
Okay, good. And then for the y values, you're just negating them. So give me those new y values, please.
Um, 0, -2, 0, 2, 0.
Now, maybe that when you're in class or you look at the problem again, they do it just with the graph. I think it's easier to do with the table. I feel like that is kind of your best way to get the right answer. So we're going to graph. And I'll do that in red here. You're going to graph. So -4, 0, -2, 2, 0, 0, 2, 2, and then 4, 0. Now what's harder about this one is you have to recognize that it flipped. So it looked like this now. Let me go that way. And so it actually comes down this time forever.
Okay.
So now we can do domain and range stuff, but go ahead and get that down. I'm gonna step away for seconds and we'll be right back though.
Okay.
I'm back and we're gonna do domain and range now on this.
Okay.
Let's see if I actually grab that snip. I did. Okay. So again, the domain is left to right here. So while this goes down forever, it also goes to the left forever.
Mm-hmm.
Okay, so how far left is for forever?
Is it -infinity?
Negative infinity. And then what is the rightmost x value of the red? The rightmost x value of the red?
4.
4. Okay. The range is bottom to top, or you can think of it as min to max. How far down does this go?
-infinity.
Okay. And then what's the peak? What's the highest y value? What's the largest y value that you see in this list?
2.
Actually, there's a mistake in here. That's not good. It doesn't change much, but it will in picture grade. So there's like that. Like that. Sorry about that. You want to, but yeah, to answer that question for the range, it is 2. The 2 bracket.
Okay.
Should also double check that you're using interval notation. I really don't know where you're at in this course. I think that's pretty standard in college algebra, but not
Yeah.
sure. All right. So let's see what we can do on the next one. Guess we can sort of start it. Question 5. So it says here, in most state highways, the fine for speeding depends on the speed of the car. In certain states, suppose the fine is a function of the number of miles per hour of the speed limit is f of n. The graph of this function is shown below. So what they're showing you here is that this is the miles over the speed limit.
Mhm.
So if you're 0 miles an hour, there's no fine. If you're 5 miles an hour, or let's go use 10 miles an hour over, it's $50 fine. I'm sure it is much higher than that. But that is what we've got here. And so on here. You can see that, right? So now what are they asking you to do? And we're not probably gonna get very far into this, but it says, first part here, it says, the state determines that the fine at every speed should go up by $20. So that sounds like every speed. So I'm a little unsure here. So might be a good place to stop anyway. Because I don't know if they mean like $20 per mile per hour or $20
Mhm.
per 5 miles per hour.
Oh, okay.
Or is it, so you may want to ask that, get some clarification on this. I don't know. And we'll want to maybe definitely figure that out. Okay, we'll go ahead and stop
Okay.
here for today. I just did see you scheduled another